8 months ago, I said something that kept bugging people kind of a lot. And what we normally call entropy is just the lack of our ability to keep track of what's really going on. So I built a habit around that idea and I gave it a name, and it's called Recursive Predictive Structure. You make a prediction, you check what you got right, you check what you got wrong, and then you check what you didn't really make a difference in. And instead of taking those failures or errors and those ambivalent changes and throwing them in the trash, you turn those all into features. You fold it back in and then you repeat that process. And that's it. It's not mystical or magic. It's not tech jargon. It's just stop wasting that part that didn't fit. In a nutshell, it's just saying that humans shouldn't be so audacious to assume that there is a chaos just because it is a chaotic looking thing to them, and that they don't have the mental architecture to reconstruct that structure, which is not in fact chaotic. Only the mathematics is not sufficient enough for humans to articulate it or predict its interactions. And now there's a fresh new physics theme on the scene. Almost the same thing, but from a different angle. I'll post the article in the link below, but I want you to understand the similarities. A team took the first law of thermodynamics into a messy place. It showed that the old accounting for this data was leaving out crucial data. And these are very crucial energy channels. Turns out when you add the missing terms, the mystery loss shrinks. It doesn't necessarily kill entropy, but it kills laziness. Basically, it says if the system looks leaky, maybe your description is. Maybe your calculator doesn't have enough buttons. And that's pretty much the core of what I've been doing for quite a while now. Not to mention, I've just been imagining this. I call it a no entropy stance, but you got to hear me clearly on this. I'm not promising perpetual motion. I'm simply promising better and more thorough notes. Yeah, this is probably just noise to most of you, and it likely is if these scientists who are doing this independent study themselves are also wrong. And then you can look at everything else about entropy and call it also noise. You can relate it directly. You can say, wait a second, is that noise trying to tell me something? That was just kind of a clever little usage of entropy and my actual message here. Don't worry about that. But back to entropy, before you average it away, see if it repeats. If it repeats, it's a pattern, obviously. And if it doesn't repeat, then you probably haven't been watching for long enough. Think about that. And you probably aren't in the exact same position of observation of your initial observation. I mean, you most certainly are not. And it's not even about actually your position. It's about the entire construct, the entire state, the current state of the universe in that moment. So when the universe is expanding, it's a completely different state. It's different than you just moving through space. It's you actually existing and the universe existing in a present state. So the present is the state of the universe. It's not like it's hard to explain. It's really hard to explain. Now, it's so hard to explain that I wrap all of that whole idea into a bigger frame that I call absolute existence, absolute perception, absolute precision, absolute position, absolute focus. And those are just names that help me to keep track of what I'm talking about within those papers, but don't let that scare you. It's just kind of reminders of what we're talking about. I'm making my own terminology because to explain these things, I don't really have the words to explain all of them. And if they do exist, I'm not smart enough to know them. But with absolute existence, you're never outside the system. Everything counts. Absolute perception is observation, is a coupling, not a snapshot. Simply looking changes the math, and you see this in quantum mechanics. absolute precision, which means that the world is often sharper than we assume. We blur it with lazy variables. To understand that, you can think of a rock as a lump of stone that is malformed, but when you zoom into it, it is perfect. All of the molecules line up exactly correctly. Every time, they always line up correctly. The universe doesn't accidentally miss a molecule or miss a link somewhere or accidentally put the wrong molecule somewhere, unless the conditions present that in some sort of physical or chemical way. Absolute position, the context, it all moves. Your lab, your planet, your fields, they're never the same twice. Absolute focus, you need both wide angle and zoom, pulsing between them with purpose, with a persistence as well. And if you put all that together with recursive predictive structure, or RPS, rock, paper, scissors, you get a way of working. Wide first, sweep for the broad, repeating shapes, then zoom, write the term that explains the repeat, back out, you sweep again, zoom again, soft focus to find the trail, hard focus to carve it in to the ledger. And then you have the persistent to never forget. And that's the kind of temporal rhythm that you can use to drain the word random of its actual power that we use. And it's really just an excuse or a way or a word that we use to say that I give up. All right, to come back, and ground it so we're not sounding like a crackpot here. So you heat a balloon and it expands. The easy ledger is going to be now take a steamer of solar plasma with twisted magnetic fields flowing, reconnecting, throwing off bursts. The old ledger density, pressure only, gets you halfway. Energy seems to disappear until someone writes down the coupling you never counted. Suddenly the loss has a line item. That's all I'm really saying. Everywhere, keep adding the lines that your errors are begging you to add. Now, obviously, you want an automated process to do this, and that's the universe for you. That's what we're going to get here. In the terms of computation, that's easier said than done. So back down here on the ground, in a lab, your instruments, they drift. You tag it noise, and then you move on. Or you can chart drift against time of day, outlet harmonics, building vibrations, barometric pressure, solar activity. If one of those stick, or maybe you get the more sensitive instruments or the correct temporal instruments to actually detect these changes, if one of them sticks, now your drift graph isn't random. It's a proxy sensor for a field you forgot to model. This is how entropy gets smaller because your attention got bigger. It's almost as easy as saying that the universe is only so big as you can see far. Like I said though, almost as easy. In code, we treat residuals like trash, minimize them, and brag about the loss going down. With recursive predictive structure, residuals are ore, like metals and mining ore. Mine them. Do they cluster? Do they cluster in a certain regime? Do they flip sign with the input crosses the boundary? Do they rise with temperature or fall with time? If the error has a shape, you just carve a space for it in the state. On the next epoch, watch the loss drop for the right pressure or the right reason. In biology, the same lesson keeps repeating. It's kind of in your face with biology, because biology has this almost anything can happen kind of deal, but it has this recursive predictive structure that it adheres to. It literally adheres to this predictive structure when you're talking about biology and life. And then you can kind of imagine what's going to happen if you can put your finger on the different variables and dynamics of an environment and the stressors and the deficiencies and efficiencies that are presented in any of those environments, and then you can somehow have the math to calculate all of that, and then you can understand the previous variables that you were not present for, and then you can calculate all of those maybe if you can figure out all those variables, because these are just variables that do exist. They are just fleeting to the architecture of our brain, because it's really hard to measure something that you're not there to measure, right? So the idea is these variables exist, you just don't know them. That's the bottom line of recursive predictive structure and zero entropy. Now, I'm not saying that this team is saying that there's zero entropy. What I'm saying is I'm saying that there's zero entropy. They're saying some things that are kind of in alignment with what I'm saying, and it seems like the more little scientific articles that come out, they're getting closer and closer to what I'm talking about, and they're never really coming out and saying it, but what they're saying is remarkably similar to what I am just fully laying out. They're kind of incrementally getting closer and closer, where I'm just like, look, how about we just get to the end and say this is the answer? But I digress. But in biology, the same lessons, they repeat. We used to act like DNA was just a file cabinet. Then we watched light, fields, and structure playing together. That's biophotons. Coherence windows. Epigenetic marks and signals once dismissed as noise. It turns out that life doesn't waste its errors either. It listens and records and adapts and pushes towards what it worked for. And by doing that, whatever works for it, it retains if that was successfully passed on, obviously. And then sometimes it doesn't even need to have been passed on. Sometimes it's spontaneous. Sometimes it's a direct input from the environment itself. It's like there's a baby in the womb. Oh, dang, those babies are different because of the difference in the environment. Now, I understand that's really extreme, but you cannot say that it has never happened. Now, scale up again. Gravity and structure formation look messy until you track the gradients that matter. Where density piles, where fields drag, where geometry latches. The universe is not simple, but it's consistent. Simply put, if something can't be predicted 9 times out of 10, we mean we haven't collected the right handles. This is why I'm pretty stubborn about my own coined phrase, a ban on entropy. Like, I literally, within my own framework of thought and processes, I ban entropy. I'm like, dude, don't talk to me about loss. And if there is some form of loss, go ahead and log that for me so that I don't lose it and I can figure out how to use it. I don't look at it as defiance, though. I don't look at it as kind of rejecting mainstream science. I look at it as I have not been in mainstream science because I have not been into college. That's what I'm saying. It can be seen as a posture. I mean, it's me telling myself, don't hand your ignorance a crown. You gotta pay the cost. Heat still burns. Batteries still empty. And wear still happens. But don't add fake costs by refusing to look. And that's just saying it's just how it is. This careful team extended a bedrock law, literally, and that book's balance better. It really does now. That means that the map is becoming smaller than the territory. This is kind of what changes everything. Treat prediction error as a teacher, not a shame. You get it? Error is your teacher. It is not to be ashamed of. I mean, that's kind of how society teaches us. It's if you make an error, you have an accident, something doesn't look exactly right, then you should be ashamed. And it kind of discourages people to continue trying. So if you look at it as an opportunity to see why you failed or what that was, then you have an opportunity to say, I'm not going to do that again. What I'm going to do is try something else. And you're going to try things until it works, and you're going to log all of the fails. The reality is most systems, they don't function that way. And this is more than just, talking about people and everything. I'm really talking about computation, and I'm just putting it in a way so that we can all understand it. Recursive predictive structure basically just says, if the mistake repeats, it's your next variable. If it doesn't repeat, you need more resolution or better sensing. Either way, the error points the way. Secondly, there's cadence. You don't stay zoomed in. Don't stay zoomed out. You pulse. Soft focus to catch the field, hard focus to write the term, pulse again, and then you got this persistence to tie everything in. Come think of it, it's kind of like my law of 3. but the alteration keeps you from overfitting the twig or missing the forest. And it's also how our attention actually works when we're at our best. But don't forget to always respect position. I don't know how to make this abundantly clear, like position or the state of the universe. It's so important. Your seat, your room, your city, your planet, they're all moving through these fields that you don't know about and that you don't even feel. It's literally happening all the time. You may have to expect for shallow repeats that don't even really line up all the way until you can understand how a pattern truly functions in the universe, because what we're taught in grade school is how a pattern is very distinct in how it works. But if you were to take a step back from everything, you could see that there are patterns within prime numbers, there are patterns within phi, there's patterns within pi, there's patterns within all of these things that if you had a big enough view of it, it would be a pattern. If you were able to be alive for long enough and count that high, you would see the pattern. It's basically the bottom line, because you're ultimately waiting for the universe to put you back in the same exact position that you were, or the exact state that you were when you initially did the experiment. So if you never go back to that same universal state, which means you can never be as young as you were when you did it, how can you ever repeat a scientific experiment? So our abilities to measure anything within this universe is our number one blockade on actually being able to understand what it is we are actually trying to exist in and trying to recreate with math and computers and technology. I'm really sharing this because it's been useful. Not because it's perfect. I mean, it's not perfect by any means. And I'm not a scientist. I'm just a guy. And I'm in my garage here, and I like to talk about sciencey stuff, and I like to do computery things, and I really like to do stuff that make me feel like I am looking at something that no one else has ever seen before. And I'm probably exactly doing that, and I could be totally crazy too. So I mean, don't take me as like saying that all my facts are like true and then you should take them and you should go study me and stuff like that, or the words that I'm saying. I'm just saying that I said something a long time ago and I've been talking about it a lot on the internet, and now there's like actual scientist teams like kind of making stuff, like doing tests and stuff that align with my work, and it's not refuting it at all. It's just like they're like if I have this whole picture laid out right here, like this, like let's say this is my picture. They are doing like articles that do this. It's like, oh yeah, it fits right into my little picture here. And then another article comes out over here and it fills in another little gap. And then boop, 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 boop. And then eventually they're just gonna fill up my whole freaking hypothesis. So at that point, I guess I can use their articles as evidence to my hypothesis to make it a theory, right? And then it could be true, maybe. I mean, whatever. I have like at least 13,000 lines of mathematics for my hypothesis, and I have at least a lot more description, like in papers, like a whole bunch of just descriptions of the universe, you guys. But the main thing is entropy. Entropy is like the thingy that we're focusing on right now, and I'm happy to see that there are scientists out there that are starting to look at entropy and say, what are you really? What's your real name? Like what are you really doing? Because like, you got to think about it. How can something be chaos? What? That don't make any sense. Chaos, really think about it, has no purpose. That doesn't make sense. And then people will say, well, humans are in life and stuff that has no purpose. How? Explain it. And you know what? It's really hard to explain why there would be no purpose without just hand waving it away. It's really hard to say that. And you know, it's really hard to say why there is a purpose too. It really is hard. I mean, for me, it's really simple. It's like the universe wants to touch itself. That is why we exist. That's why the universe exists. That's why the Big Bang actually happened. And in my own mind, the Big Bang is an imagination. It is something that it's fucking crazy, actually. It's literally something that some unstoppable force, which is an urge or, a thought, this unstoppable force tries to come into contact and touch self, which is absolute existence, this immovable object. The immovable object being absolute existence, the entire construct, and then absolute existence urge to touch itself. It cannot touch itself. It could not touch itself. So it imagines this. Imagines all the ways that things that it is made up of could touch itself. And what happens from there is the Big Bang. When it begins this imagination process, the Big Bang occurs. And then all these infinite possibilities start to happen. They start to unfold, touching each other in different ways, in the infinite amount of ways. And once everything has touched each other in the infinite amount of ways possible, the Big Bang will have reached its limits and then begin to compress back down. And then all that will fold in on itself and then deposit itself into absolute existence, understanding as a thought. It'll all culminate into the absolute thought in order to give absolute existence a better understanding of how it can touch itself. And then what happens? It tries to touch itself again with that urge, but it still can't. So another Big Bang occurs until the thought process becomes shorter and shorter because it learns and it gets better and better until absolute stability occurs and it finally achieves the moment of touching itself.